Hello ladies and gentlemen, it is time for the 8.1 to 8.4 crash course. So we're going to see if we can get through this entire unit in just a few minutes. The first question asks us to plot an ordered pair on the polar coordinate system. So 3, 2 pi over 3. 3 tells you that you are on not the first radius, not the second radius, but the third circle here. So we're on the third circle, 1, 2, 3. And 2 pi over 3 is your reference angle. So you guys should know that 2 pi over 3 is up here somewhere. If I want you to plot the point 3, 2 pi over 3, 1, 2, 3, that puts you right there. That is 3, 2 pi over 3. But in polar, you can write that ordered pair a lot of different ways. So let's start with sort of the easiest one. If I still say I'm on the third circle, instead of describing this angle in the counterclockwise fashion that we're used to, I could also do it in a clockwise fashion. So if I wanted to describe that angle clockwise, that's 1, 2, 3, 4 pi over 3s, and that would be negative 4 pi over 3, because when we go clockwise, we say the angle is negative. Those are the ones that are relatively easy. The tricky ones are when the radius is negative. So, when the radius is negative, what I do is I think if I came over here to this reference angle, I'm now going to describe this angle two different ways. And let's do the first one, negative 3. If I said that that was negative pi over 3, why does that end up in the same place when the radius is negative? Well, if I say go to negative pi over 3, what you would do is you would come down here to negative pi over 3, and you'd be on this line somewhere. If the radius was 4, that's radius 4, that's radius 3, that's radius 2, that's radius 1, radius 0, then this would be radius negative 1, radius negative 2, and radius negative 3. So you describe the angle that is pi radians across from the point you're trying to plot. Instead of 2 pi over 3, I'm going to describe this angle down here. That's if I go clockwise, it'd be negative pi over 3. But I could also describe this down here as going the long way, positive 5 pi over 3. So there's 4 different ways I can describe that same ordered pair, but all of them are referencing this point up here. Let's do some polar conversions. You should remember that this is essentially the Pythagorean Theorem. If I draw a triangle here, and I say that this is x, and this is y, and that is r, and that's theta, then x squared plus y squared would be r squared. X, well, r cosine theta is x. Well, let's maybe start over here. If I said the cosine of theta would be adjacent over hypotenuse, so x over r. And then I would multiply both sides by r, and I get r cosine theta. I could do the same thing with the sine of theta. The sine of theta would be y over r, so y is r sine theta. And then the tangent of theta would be opposite over adjacent, so y over x. These are the 4 main things that you need to convert polar and rectangular. And you can use them pretty interchangeably. It just depends what you're trying to do. If they give you an equation that says go from polar to rectangular, the first thing I'm going to do is I'm going to say, secant, that's 1 over cosine, so I'm going to put the cosine in the denominator. Now, when I see something like this, I'm trying to figure out which of these could possibly help me. I see an r and I see a cosine theta, and I'm thinking, it's got to be something like this. But r's got to be next to cosine theta. So what I'm going to do is multiply both sides by the cosine of theta. And when you do that on the right side, they cancel out, and you just get 2. So how does that help you? Well, now you have r cosine theta, which we know is x. So if I'm trying to convert to rectangular, I'm not allowed to have any r's and thetas. I'm only allowed to have x's and y's. Cool, that's x. X equals 2. No more r's and thetas. I'm in rectangular. So that's my answer. If they give me a polar coordinate and ask me to convert it, what I'm going to do is I'm going to sketch that. So negative pi over 6 is in the rectangular plane in the 4th quadrant. And remember, this is r theta, so the radius is 4, and theta is pi over 6. If you want to think of it in degrees, that's a 30-degree reference angle. If you know your special right triangles, this is a little bit easier because I know my special rights. I know the way I normally think about this is, if I draw it the same way, across from 30 degrees is x, across from 30 degrees is x radical 3, and the hypotenuse is 2x. So in this problem, 2x is 4. That means they've doubled all the sides. So instead of x, I'm going to say 2 times 2, which is, 1 times 2, which is 2. And then this will be 2 radical 3. If x is 2, then x is 2, so 2 radical 3. I've got my order pair, but I need to be careful. I'm in the fourth quadrant, so this is actually a negative value. We're below the x-axis, so my coordinate would be 2 radical 3, negative 2. Now I have it in rectangular form. This is polar, r theta. This is rectangular, xy. I'm going to do the same thing, but I'm going to start in rectangular now. So I need these again, these conversions, and I got to figure out which one is most appropriate. Let me just screenshot them so I don't have to keep flipping back to here. Okay, we'll take that, and we'll put that here. Okay. So what do I know? I know that x squared plus y squared is r squared. Cool, I can get rid of all that in one step. That's r squared equals 16. Now if you're writing an equation in polar, you normally want the equation to say r equals. So what I'm going to do is square root both sides, and I get r equals 4. Now, technically, when you square root both sides, you should say plus or minus 4, but in polar, a radius of circle 4 is the same as a radius of circle negative 4, so you can kind of just say, it's the same thing, don't worry about it. What if we're going from rectangular to polar, and I'm talking about coordinates? Well, on the rectangular plane, negative 2, 0 is right there. That's left 2, up 0, that's negative 2, 0. How am I going to describe that in polar? Well, again, you could do it a bunch of ways, but most of us are going to say, how far is that point from the origin? What's the radius? The radius is 2. I also need theta, so what's that angle? And we usually do it in radians. That angle would be pi. So in polar form, this is r theta to pi. 8.2, graphing polar equations. So we did a little bit of this. R equals 3 is a circle with radius 3, so that's 1, 2. That would be, I could do better. That would be this circle right there. R equals 3 is a circle with radius 3. That's the same as R equals negative 3, as I was just talking about. Theta equals 5 pi over 6. Theta equals 5 pi over 6 is a line, so find 5 pi over 6. That's right here, but it goes all the way through, and we're going to put arrows on both ends because it's a line. That's it. Find 5 pi over 6 and draw a line through it. Just make sure it goes all the way through the axis. Rose equations, okay, so there's a little trick that we used. When this is even, then what ends up happening is you have a rose petal with 4 petals. It's twice as many as you think. Let's see if I can draw this. This is kind of fun to try. It'd be like this. Ooh, that's pretty good. It would look like that. But there's 4 petals. If it's even, you double it. If it's odd, when I do the same thing, if it's odd, you don't double it, it's actually that many. And they're spaced apart that way, so they would be 120 degrees apart. I think it would start, let's see, try this again. It would look something like at 120, 240, and 360, so it would be like this. Oh no, I went the wrong way. Something like that, okay? And you could use Desmos if you had Desmos, so let me bring up Desmos and we'll try it. 2 cosine r theta. We're trying to graph 3 theta. 2 cosine 3 theta. And I'll say r equals. And it'll probably, yep, there we go. So it looks like that. Each rose has the length of that value there. So it's kind of fun. And if I want to check the other one, 3 cosine 2 theta, r equals 3 cosine 2 theta, you get your petal with 4. Or your rose with 4 petals. That's graphing polar. We didn't do a ton of that. Polar form of complex numbers. Okay, so you need to know, first of all, when it says trigonometric form, your answer must look like this. R is on the outside, cosine theta plus I sine theta. And you might notice here, I'm being pretty specific. I don't want any negative angles, and I don't want any negative radii. So make sure you pick angles between 0 and 2 pi. The point 1 plus radical 3i on the complex plane, so if I draw a complex plane here, remember that this is the real component, be an r. And this is the imaginary component. When I draw it, 1 plus radical 3i would look something like this. This is the point 1 plus radical 3i on the complex plane. So the real component is 1 and the imaginary component is radical 3. You might remember that 30, 60, 90 triangle I was talking about again. This is the x radical 3, and 2x, which means this is a 60-degree reference angle, and the hypotenuse would be 2. But if you don't, you can still use Pythagorean Theorem. and you can get r squared. 1 plus 3 is r squared, so 4 is r squared. That means the radius is 2. So I need to write this in the trigonometric form, so I need to know that the radius, check, and I need to know that the theta is 60 degrees, but it's got to be in radians, so I'm going to write this as 2 times cosine of, the angle that I'm referencing here is 60 degrees, which is pi over 3, plus I sine, again, same angle, pi over 3. So when you write it out, the things that you're filling in are the radius 2, the angle pi over 3. And that's it. You just have to make sure you write it in the right form. The radius is positive, and the angle is between 0 and 2 pi. If you would have said negative 5 pi over 3, that's wrong, because it's not between 0 and 2 pi. What if I give you two complex numbers in polar form, and I ask you to find their product or their quotient? Well, to find their product, you might remember that you multiply the radii, so the new radius will be 15, and you add the angles. When you multiply the radius, you add the angles. So I need to do 2 pi over 3, that's a nice 3, plus pi over 6. Well, those don't have a common denominator. Oh my gosh, fractions. This is 4 pi over 6, and this is 1 pi over 6. So my new angle will be 5 pi over 6. So when I write this now, it's going to be the cosine of, not 2 pi over 3, not pi over 6, but their sum, 5 pi over 6, plus I sine 5 pi over 6. And now I've got the product. Similarly, to find their quotient, you divide the radius and you subtract the angles. So divide 3 over 5, my new radius is 3/5, and I need to subtract 2 pi over 3, which I just figured out is 4 pi over 6 minus 1 pi over 6, which will give me 3 pi over 6, which is a nice way to get this question marked wrong, because that's not reduced, that's pi over 2. So make sure you reduce your fractions. Now I have cosine of pi over 2 plus I sine pi over 2. And now I've got the product and the quotient in trigonometric form. Let's try, oh wait, where am I? I lost us. Did that, there we go. Vectors. So, magnitude and direction. Vectors v, 1, negative 2, and u, 3, 5, but I want v from the initial point, negative 3, 5. So let's start with that. Start at negative 3, 1, 2, 3, 1, 2, 3, 4, 5. Okay. You can think of vectors as sort of giving your friend directions. This is like saying go right 1 and go down 2. So if you start at negative 3, 5, and I tell you to go right 1, down 2, then you're going to go right 1, down 2, and that's where you will end. But when you draw a vector, you need to indicate that where you started was the initial point, negative 3, 5, and the way we indicate where you're ending is we put a little arrow on the end. So you start here at negative 3, 5, and then you go right 1, down 2, and you would then end, this is vector v, you would end at negative 2, positive 3. I'm going to do the same thing with u, start at positive 2, positive 2, and I'm going to go to the right 3 and up 5. So right 1, 2, 3, up 5. 1, 2, 3, 4, 5. Put a dot, and I'm drawing from the initial point to what we call the terminal point, and that is vector u. So vector v, right 1, down 2, vector u, over 3, up 5. Right 3, up 5. Vector v has a magnitude of 6 radical 2 and a direction of 5 pi over 4. So 5 pi over 4, where's 5 pi over 4? 5 pi over 4 is in the third quadrant, and I always think of this as a 45-degree reference angle. This is 45 degrees. And the magnitude is 6 radical 2, so that's 6 radical 2. You might remember that if you have a 45, 45, 90, it's x, x, x radical 2. So if this has 6 radical 2, that means that this has to be 6, and that has to be 6. But since you're in the third quadrant, remember, they're both negative. So how would we describe the vector? Well, we need to start from here, and we need to go left 6 and down 6. So we would say negative 6, 6, and we put that in component form. Oh, that's down here. Negative 6, that's negative 6. Left 6, down 6. So negative 6, negative 6. We can write the same vector in different forms we can use in terms of I and j. Remember, I is the vector when you go to the right 1, and j is the vector when you go up 1. So if I wanted to go left instead of right, I would say, well, that's negative 6 of those I vectors. And if I wanted to go down instead of up, I would say that's negative 6 of those j vectors. So we have it in component form with the less than greater than symbols instead of parentheses. And we have it in ij form where you basically just say, okay, this guy needs an I, that guy needs a j, and you write it out. It's a little bit easier to combine like terms and perform operations when you're in terms of I and j. And that's what we're going to do lastly, is I'm going to now find 2v minus u in component form. So you can do this in terms of I and j, or you can just kind of mess with it in terms of the component form. If I say what's 2 times v, that's called a scalar. I'm going to double these. Basically, if I said go right 1, down 3, and then do it again, you'd say, well, why don't I just go right 2, down 6? That's 2 times the vector v. Minus vector u, which is 2, 4. So when I do 2, which is like saying go right 2, and then do the opposite of doing that, left 2, 2 minus 2, my new vector would be 0, and negative 6 minus 4 would be negative 10. So that is, in component form, 0, negative 10, which is kind of like saying, just go down 10. V plus u in terms of I and j. So let's convert these into I and j. This would be 1i minus 3j, and I'm going to add, because it says add, 2i plus 4j. If I convert everything into I and j, what I was saying before is it makes a little bit more sense when I start to think of it this way, because I'm just combining like terms. 1 plus 2 is 3i, and negative 3 plus 4 is 1j. So what's u plus, or v plus u in terms of I and j? 3i plus 1j. Just combine like terms. And the last thing is find the magnitude of 2v. So if I say what's 2v, people will say 2, negative 6, and that will be their answer. You know how to find 2 times v, but that's not what I asked. See these absolute value bars? The absolute value bars are saying what's the magnitude of that. So if you think of the vector 2, negative 6, that's saying go right 2 and down 6. I want the magnitude of this vector, and to find the magnitude, you need to do Pythagorean Theorem. So 2 squared plus negative 6 squared, which would be 4 and 36, which is 40. If I square root 40, I'm pretty sure that 40 is not prime. So 40 is 8 times 5. So the way I simplify radicals is I look for perfect squares. The magnitude would be radical 40, which simplifies to 2 radical 10. So the magnitude of 2v is 2 radical 10. Make sure you answer the right question. And ladies and gentlemen, this is our last test, so good luck and have a good summer, because this is the end.